Here is a question that most people never ask themselves honestly. When was the last time you did something for the first time? Not something slightly different from your routine, not a new restaurant or a new television series. Something genuinely new. Something that required you to learn a skill you had never attempted before. Something that made you feel slightly uncomfortable because you were not yet competent at it. Something where failure was possible, where you could get it wrong, where the learning curve was steep enough that progress required real effort. For most adults over 50, if they answer honestly, the answer is years ago. Maybe decades. And this is one of the most consequential silent contributors to cognitive aging that the research has identified. Your brain, the brain you have right now at 50 or 60 or 70, is not a fixed organ. It is not running down like a clock that cannot be rewound. It retains, throughout your entire life, the capacity to form new synaptic connections, to grow new neurons in specific regions, to reorganize its functional architecture in response to new demands. This capacity is called neuroplasticity, and it is not theoretical. It is documented at the molecular level, in BDNF expression, in synaptogenesis, in the formation of new dendritic spines on existing neurons, and at the functional level, in brain scan studies, showing measurable increases in gray matter density, functional connectivity, and regional activation patterns following specific types of learning in older adults. But neuroplasticity does not activate automatically. It does not respond to passive experience. It does not switch on from watching educational videos, including this one. It activates specifically and powerfully in response to one thing: challenge. Genuine, effortful, at the edge of your current capability challenge. The research from neuroscientists at the University of Texas and Carnegie Mellon, studying what they called productive failure and desirable difficulty in the context of adult learning, has established that the cognitive benefit of any learning activity is directly proportional to the degree of effortful processing it requires. Activities that are easy and familiar produce almost no neuroplasticity benefit. Activities that push against the boundary of current competence, that require focused attention, repeated failure and correction, and sustained cognitive engagement, produce powerful neuroplasticity responses. And the specific types of learning that most powerfully activate these neuroplasticity mechanisms. We're going to discuss them in detail today, because not all mental activity is created equal, and most adults over 50 are spending their cognitive leisure time on the activities least likely to protect their aging brains. By the end of this video, you are going to understand exactly what your brain needs, and you are going to have a specific research-backed learning protocol that you can begin this week. Let's establish the precise neuroscience of why effortful challenge produces neuroplasticity, while passive activity does not. The key mechanism is the relationship between neural activity, BDNF expression, and synaptic strengthening, a cascade that we've been supporting nutritionally throughout this series. When neurons are activated together, particularly in patterns that are novel and require sustained engagement, they release BDNF into the synaptic cleft. This local BDNF release acts directly on the activated synapses. It promotes the growth of dendritic spines, small protrusions where synaptic connections form. It increases the density of AMPA receptors, the primary glutamate receptors that mediate synaptic strength, and activates gene expression programs for long-term maintenance. This synapse-specific BDNF release is the molecular basis of the Hebbian learning principle. Neurons that fire together wire together. But this only occurs when neural activation is sufficiently strong and sustained. Weak, familiar activation from passive activities does not reach the threshold. Strong, sustained, novel activation, the kind produced by effortful learning of new skills, produces robust synapse-specific BDNF release and the synaptic strengthening it drives. This explains why watching television produces minimal neuroplasticity. The processing is largely automatic and does not require novel pattern formation or error correction. The second mechanism is the formation of new dendritic spines through spinogenesis. Two-photon microscopy allows us to visualize these individual synaptic structures in real time. New dendritic spines begin forming within hours of novel learning and stabilize into persistent structural synaptic connections over the following days. In older brains, the response to effortful novel learning remains significant. Research has documented spine growth in older adults following novel skill learning. The aging brain is not incapable of growth. It just requires stronger stimulation, more genuine novelty, to reach the activation threshold for neuroplasticity. The third mechanism involves cognitive reserve, the brain's capacity to maintain function despite pathological changes like Alzheimer's or brain atrophy. Cognitive reserve is not fixed. It accumulates through cognitively stimulating experience and can be actively built after age 50 through the right types of learning. Research has documented gray matter density increases in adults in their 60s and 70s, demonstrating that building reserve is genuinely possible at any age. Not all novel learning produces equivalent neuroplasticity benefit. Research has identified specific categories of learning that most powerfully activate the neuroplasticity mechanisms described. Understanding the differences allows you to direct your cognitive enrichment effort toward the highest impact activities. Category 1. Musical instrument learning. Of all the activities studied, musical instrument learning has the strongest evidence for neuroplasticity in adults over 50. Learning a new instrument simultaneously engages auditory processing, fine motor control, visual reading, temporal pattern recognition, emotional regulation, and memory. It is the most cognitively demanding multi-domain learning activity that most adults can realistically pursue. Older adults who learned piano over 6 months showed measurable increases in cortical gray matter density in the auditory cortex and cerebellum. The gray matter increases reflected genuine structural neuroplasticity. A study found improvements in auditory memory, processing speed, and critically, in BDNF blood levels. The BDNF increase from musical learning was comparable to aerobic exercise, adding a second high-impact activation pathway to your protocol. You do not need to become proficient. The benefit is highest during the learning phase, when the activity is still challenging and error correction is required. Category 2. Visual arts and complex craft skills. This includes drawing, painting, woodworking, or any visually complex fine motor demanding craft. These require sustained attention to detail and the development of novel perceptual skills that were not previously part of your repertoire. The key mechanism is the development of expert perception, the ability to see the world differently as a consequence of trained visual attention. Category 3. Language learning. Learning a new language after 50 is one of the most extensively studied and evidence-supported cognitive activities. The demands are comprehensive: phonological processing, semantic memory, and continuous inhibition of the dominant language to access the new one. Bilingual adults show significantly later onset of dementia symptoms compared to monolinguals. Language learning builds cognitive reserve in critical networks. Even modest engagement for 20 to 30 minutes daily produces measurable cognitive benefits over months of consistent practice. Category 4. Complex social and strategic activities. Activities like chess, bridge, or Go require modeling another person's mental state. This activates the same prefrontal and temporal circuits critical for resilience in a socially engaged context. Strategic games, where thinking deeply produces better outcomes than chance, are the ones that provide the effortful engagement that drives neuroplasticity. Now let's address the uncomfortable truth that neuroplasticity research forces us to confront. Most mental activity adults over 50 engage in produces minimal benefit. The specific categories of mental activity research found to be largely ineffective for building cognitive reserve include passive entertainment like television, streaming video, and social media scrolling. These activities engage the brain at a low level of effortful processing. The brain's role is predominantly that of a passive recipient. No error correction, no skill development, no sustained effortful pattern formation. The threshold for significant BDNF release is not consistently reached. Research comparing passive entertainment versus active skill learning over 5-year periods found dramatically different cognitive aging trajectories. The passive group showed faster cognitive decline despite equivalent engagement. Hours matter far less than the effortful quality of that engagement. Familiar activities, doing the same crosswords for 20 years, reading the same genres, or practicing old hobby skills for decades. These maintain existing circuits, which is valuable, but they do not produce the novel pattern formation that drives neuroplasticity beyond maintenance. The critical distinction is between activities you can do while partially autopilot, where your existing neural circuits are sufficient, and activities where your existing neural circuits are genuinely insufficient and must grow. Only the latter category produces neuroplasticity. Research on crossword puzzles found that while enthusiasts developed superior performance over time, they did not show broader cognitive reserve building. Crosswords build specific competence without building the general neural architecture of cognitive resilience or reducing dementia risk. The key question to ask of any cognitive activity is, am I getting better because I am learning, or because I have gotten comfortable? When an activity stops being challenging, when you can do it without significant effortful attention, it has reached its neuroplasticity ceiling. That is the signal to either advance to a higher difficulty level within that activity, or to introduce a genuinely new learning challenge. Now, let's build the cognitive enrichment protocol, with specific guidance on how to select, implement, and progress through novel learning activities. These activities produce maximum neuroplasticity benefit. The selection criteria are based on 5 characteristics that research has identified as the drivers of cognitive benefit. First, genuine novelty. The activity must engage neural circuits that are not already well developed. It must require learning genuinely new patterns. Second, multi-domain engagement. Activities that simultaneously engage sensoromotor, auditory, visual, social, and semantic domains produce broader neuroplasticity than single-domain activities. Musical instrument learning and complex strategic social activities meet this criterion. Crossword puzzles, which primarily use semantic memory, do not. Third, error sensitivity and correction. The activity must provide clear feedback about performance errors and require active correction to strengthen synapses. Fourth, sustained progressive difficulty. The activity must remain challenging as competence develops. An activity that becomes comfortable has exhausted its neuroplasticity potential. Fifth, regular engagement. Daily or near-daily brief practice produces greater neuroplasticity than infrequent longer sessions. 20 minutes daily is better than weekly blocks. The implementation protocol. Choose one primary learning challenge from the 4 high-evidence categories. Depth of engagement with a single activity is key. Choose an activity you are genuinely curious about. Intrinsic motivation is a neuroplasticity amplifier, producing greater BDNF elevation and cognitive reserve. Commit to a minimum of 6 months. Meaningful gray matter changes appear at 3 to 6 months of regular practice. The first few weeks feel frustratingly slow. This early period of struggle is precisely when the neuroplasticity response is strongest. Seek instruction. A teacher or tutor provides the error correction feedback that drives faster and more robust neural adaptation than self-directed practice alone. Embrace the discomfort of incompetence. Struggling and getting things wrong is the subjective experience of your brain forming new neural connections. Practice in the morning when possible. Memories of skills are consolidated during the sleep that follows. Morning practice is followed by a full sleep cycle. Combine learning with other protocols. Exercise before or after a session amplifies BDNF elevation, providing the substrate for synapse-specific release that learning triggers. Supplements like magnesium L-threonate and NAD+ support the machinery for structural synaptic changes. The learning protocol activates what the entire series has built. It provides the behavioral stimulus that makes the biological foundation productive. Start your cognitive enrichment today. 34 videos. And with novel learning, we have added the behavioral activation layer that makes every biochemical and biological intervention in the series more effective. Think about what we've built over 34 videos from the perspective of neuroplasticity specifically. BDNF from video 1, the brain growth factor that drives synaptic strengthening in response to learning. Magnesium L-threonate from video 2, restoring the NMDA receptor density and function through which learning-induced synaptic strengthening operates. CoQ10 and NAD+ from videos 4 and 11, providing the cellular energy and sirtuin activation that long-term synaptic memory consolidation requires. Deep sleep from video 5, the nightly window during which learning-induced synaptic changes are consolidated into lasting structural connections. The gut microbiome from videos 6 and 25, supporting the SCFA-driven BDNF production that provides the growth factor substrate for learning-induced plasticity. The anti-inflammatory protocol from video 8, reducing the neuroinflammation that suppresses the BDNF response to learning. The autophagy protocol from video 13, clearing the cellular debris that impairs synaptic function in aging neurons. The photobiomodulation from video 29, directly activating cytochrome C oxidase in the neurons most demanding of energy during effortful learning. Every single mechanism in the series has been working to optimize the biology that effortful novel learning activates. The supplements, the sleep, the diet, the exercise, all of it creates the optimal neurobiological condition for neuroplasticity. But neuroplasticity does not activate from a favorable biological condition alone. It activates from challenge, from the genuine, effortful engagement with novelty. The biology creates the capacity. The learning fills the capacity. Without learning, the brain is well supplied but understimulated. Together, they are the complete picture, the substrate and the stimulus, the capacity and the challenge, the vagal tone from nature, and now the neuroplasticity activation from novel learning, represent the dimension of brain health that no supplement can replace. Your choices about how you spend your time, what you challenge yourself to learn, are as biologically consequential as anything you put in your body. This is the complete picture of cognitive health after 50. It is not just what you eat and take, it is how you live. The biology we've built creates the foundation. How you use that foundation determines what gets built on it. Choose one learning activity from the 4 high-evidence categories: musical instrument, visual art, language, complex social strategy game. Find an instructor, a local teacher, or an online program. Commit to 20 minutes of daily practice, morning if possible. Then begin. Today. Not after you finish the rest of the protocol. Begin learning something genuinely new today. Your brain is waiting. Coming up next week, we are going into one of the most overlooked dimensions, the role of purpose and meaning, ikigai. Research establishes that a strong sense of purpose is a powerful independent predictor of Alzheimer's resistance, reducing risk by up to 2.4 times. Subscribe now. Turn on notifications. Thank you for 34 videos. The system grows more human with every edition. Stay sharp, stay challenged, stay vital. I will see you next week.